Hello and welcome to a supplementary video. This is a follow-up video to the previous video on the Edexcel GCSE paper 1MA1/3H, third paper in the higher tier. This is question 11. This is how to solve question 11 if you can't remember your quadratic formula, and this really is in case you've tried really hard to memorize your quadratic formula and you just can't. It's a good idea to know this as an alternative method, just in case during the exam the method for using the quadratic formula or the actual quadratic formula itself just disappears out of your head and you can't exactly remember it and you're not sure of the quadratic formula. So this method is the method that actually derived the quadratic formula in the first place. It's called completing the square, and we'll use this only if you really can't remember your quadratic formula, or if you're just really bad at remembering formulas and you're better at following procedures than you are at remembering formulas. So we're solving this using completing the square method. So we have x squared minus 5x plus 3 equals 0, and we're going to take advantage of the properties that a plus b when squared is equal to a squared plus 2ab plus b squared. So if we think of this as being x plus some number squared, we're going to have the middle term. If we imagine that a is our x term, then we've got half of our b term will be squared as the number in order to make this a perfect square. So I'm going to move that out of the way so that we can work with it. So we want to turn this into something that is a perfect square. So what I'm going to do then, because the middle term is doubled, so this term needs to be halved. So this half of 5 is 5 over 2, and 5 over 2 squared will be 25 over 4, which will give us our b squared. So if this was x squared minus 5x plus 25 over 4, then that would be a perfect square. But we've got this 3 here. So if we add 25 over 4 and then subtract 25 over 4, we haven't actually changed the value of this, but we have made it into a perfect square. So we've got x squared minus 5x plus 25 over 4, which is our perfect square. And now to restore it back to its original form, we've got to subtract the 25 over 4. And then we add 3, because there's a 3 here. And that's equal to 0. So we haven't changed it, but we've made it so that this can now be classed as a perfect square. So what we have now is x minus, and remember this will then be 5 over 2, squared, and that is now equal to, so if I take this 25, this negative 25 over 4 over the equals, we've got 25 over 4 minus 3. Okay, so now we need to combine these fractions, so I'm going to convert this 3 by multiplying top and bottom by 4 to 12 over 4. In fact, I'm not going to rewrite it. You can rewrite the whole thing, but I'm just going to replace this 3 with a 12 over 4. So all I've done is times top and bottom by the common denominator, which is 4. So that's 12 over 4. And now I can combine these fractions. So that's 25 minus 12 is 13. So this whole thing will become 13 over 4. Again, I'm going to save space by just writing that, but you would copy the whole thing out again. So this is plus 13 over 4. So this squared is equal to 13 over 4. So to get this on its own, all we have to do is square root both sides. And remember, if we're going to square root, the square root radical will only give us the positive or principal root, so we have to specify plus or minus if we want both the positive and the negative root. So this is x minus 5 over 2 is equal to both the positive root and the negative root of 13 over 4. So now we can take this negative 5 over 2 across the equals, so it becomes positive 5 over 2. So x is equal to 5 over 2 plus or minus the square root of 13 over 4. Now we can pull this 4 out of the square root by simply square rooting it. So we've got x is equal to, although we don't even need to do this, at this stage if you want you can just shove that into your calculator and get your answers. But I am going to pull that 4 out. So x is equal to 5 plus or minus the square root of 13 all over 2, because when that 4 comes out it's going to be a 2. So we've got 5 over 2 plus or minus the square root of 13 over 2, so which is the same as 5 plus or minus the square root of 13 all over 2, just because it's easier to shove that into our calculator, and then we'll get the same answers as we got before. But I'm going to plug this into our calculator anyway. So that's 5 plus 13 square root divided by 4, and again we've got 5, hang on, I didn't want to do that, let's try that again, 5 plus 13 square root equals divided by 2 is 4.30, so that's 4.30 to 3 significant figures. And of course remember, because this is a 2 that comes after the O, that does not round up. And then the other one is 5 minus 13 square root divided by, no, not divided by 2. In fact, I'm going to cancel the whole thing. So that's 5 minus 13 square root equals divided by 2, because the whole thing is divided by 2, not just the square root of 13. So that's 0.697 to 3 significant figures, and that 2 means the 7 does not round up. So that's 0.697. Again, this method should only be used in an emergency if you forget your quadratic formula, but it's a good idea to know this method so that if you do have a mental blackout in the exam and you just can't remember your quadratic formula, it's good to have this as a safety net to fall back on in case you forgot how to use your quadratic formula. Try not to use this method in your exam. It's slower, it means you haven't got so much time to do your other marks. So if you can use your quadratic formula, use your quadratic formula. Okay, I hope that was helpful, and I'll see you in another video.